Hello. Let us we will continue with our unit number 2 of our syllabus. So, as we have discussed yesterday about uh, uh, we have discussed that in detail. We have discussed what are the content of the units and what are the outcomes of that units. Okay. So let us we will see that first point of the unit number 2, that is the electromagnetic induction. Okay. So in that electromagnetic induction, as the name is given, electro and magnetic. So there is a relation between magnetism and electricity, you can say, or EMF, you can say. So that electromagnetic induction, that is the very important point in the field of physics. And according to the Faraday discovered that our Faraday's observations is about the magnetic flux. So can anybody say about the magnetic flux? Magnetic flux म्हणजे काय असं कोणी सांगू शकतं का? Anybody is there? You can say about this magnetic flux. So very simply, you can simplify that magnetic line of forces. Magnetic line of forces, that is called as the magnetic flux. Okay. So whenever the magnetic flux passing through any closed circuit is changes, the EMF is induced in the circuit. So what is the basic need for that electromagnetic induction? The basic need is the closed circuit. After that, in that closed circuit, when the magnetic flux is changes, right? Magnetic flux changes means magnetic line of forces are changes from 0 to certain value or for maximum value to 0 value. That means there should be the change in the magnetic flux. म्हणजे constantly magnetic flux जर असेल, आता magnetic flux म्हणजे magnetic flux is associated with the magnetic field. Okay. So whenever the magnetic line of forces are, that is the flux, it changes in the circuit, in the closed circuit, the EMF is produced in the circuit. Okay. The produced current is called as the induced current. The produced current is called as the induced current. And the electromagnetic induction, therefore you can define this electromagnetic induction, that process or this phenomena. Electromagnetic induction is the phenomena of production of EMF in the coil when the magnetic flux it changes. So you can say that electromagnetic induction, it is the process, it is the production of induced EMF in the closed circuit whenever the magnetic flux is changes. So it is called as the electromagnetic induction. समजलं सर्वांना? That is the basic concept, or that is the you can say that the definition of electromagnetic induction. Okay. So next is the Faraday's law of electromagnetic induction. So this Faraday's law, there are the two rules for the electromagnetic induction that is given by the Faraday's. So whenever the magnetic flux associated with the coil or the circuit is changes, EMF is produced in the coil or circuit. हा म्हणजे आपल्या इलेक्ट्रोमॅग्नेटिक इंडक्शनच्या डेफिनेशन सारखं आहे. So whenever the magnetic flux associated with the coil or circuit changes and EMF is induced, or EMF is induced in the circuit, or it is the flux in the coil or circuit. or you can say that the magnitude of induced EMF at any instant is directly proportional to the rate of change of magnetic flux with the circuit or with the coil. So these are the two laws are given by the Faraday's. That is, whenever magnetic flux associated with the circuit is changes, EMF induced in the coil. After that, the magnitude of induced EMF at any time is directly proportional to the rate of change of magnetic flux. So you can say that. So mathematically, you can say that. Suppose that we can that suppose that d phi is the change of magnetic flux at any time t. समझा d phi is the change of magnetic flux at any time of interval dt. Then according to the Faraday's law, induced EMF is directly proportional to the rate of change of magnetic flux. So d phi by dt, d phi is the flux and t is the time. So if you remove that proportionality, E is equal to k d phi by dt. So this is according to the Faraday's law. Okay. After that, there is a Lenge's law. What is that Lenge's law? The Lenge's law states that the direction of induced EMF is such that it opposes to the change of production. Means Lenge's law is already it is gives the direction of magnetic flux and EMF. Okay. म्हणजे Lenge's law it shows the direction. Or according to that according to the Lenge's law, direction of induced EMF is such that it opposes the change of production of it. Means you can say that E is equal to minus d phi by dt. Okay. So so what is the role of negative sign? So negative sign indicates that direction of E and direction of d phi by dt it is opposite direction. So whenever it indicates that so induced EMF it is always in opposite to the rate of change of magnetic flux. Okay, this is about the Lenge's law. Okay, समजलं सर्वांना हे? सर्वांना समजलं याबाबत? So what is the electromagnetic? आपण काय काय? So what we have discussed today? We have discussed about the electromagnetic induction. We have discussed about the Faraday's law. We have discussed about the Lenge's law. After that, we have to discuss about the self-induction. Self-induction means what? What is the self-induction? Self-induction, whenever current is flowing through the coil, what will happen? एका कॉइल मधनं समजा करंट फ्लो होत असेल तर काय होणार? कॉइलच्या भोवती काय तयार होईल? कोणती फील्ड तयार होईल?
magnetic field.
Very good. Around the coil or around the coil, the magnetic field will be created. Okay, and due to this magnetic field, what will happen? So whenever the magnetic field is created there, magnetic line of forces, that means magnetic flux will be changes. म्हणजे पहिल्यांदा कसं आपण काय केलं? आपण करंट फ्लो केला कॉइल मध्ये करंट फ्लो केल्यामुळे काय होणार की तिथे मॅग्नेटिक फील्ड तयार होईल. एंड दिस मॅग्नेटिक फील्ड what is the function of magnetic field? So magnetic field, whenever it is changes, where it is created there, that means the magnetic line of forces are going to changes. That means the magnetic flux is changes. So according to the Faraday's law, whenever there is change in the magnetic flux, EMF is induced in the coil or in the circuit. That means you can see that whenever the current is flowing through the coil, the EMF is induced in the coil. Okay, so the production of EMF or this phenomena of production of or induction of EMF in the coil when current is passes through the coil, this phenomena is called as the self-induction. Okay, that is called as the self-induction. Next point is the mutual induction. What is the mutual induction? For the mutual induction, we have to need the two coils which are very close to each other. They are not in contact with each other, but they are very close to each other. So what will happen? Whenever the first coil, two coil placed to each other, nearby each other, there is a one coil is there, first coil and second coil. Okay, we can give the name first coil and second coil. So current is flowing through the first coil. Okay, whenever the current is flowing through the first coil, it will produce the magnetic field. An induced EMF will be developed in the coil, that is called the self-induction, that we have already discussed. So what is happening? Whenever the magnetic field is created in the first coil, the second coil, it is in the it is very close to first coil. So it is in the magnetic field created by the first coil. So that what will happen? So as second coil is in the magnetic field of the first coil, some magnetic line of forces, that means the magnetic flux of the second coil will be changes. Okay, so whenever the magnetic flux of the second coil is changes, that means according to the Faraday's law, whenever there is change in the magnetic flux, EMF is induced in the coil. So whenever we are going to apply the current to the first coil, EMF of the second coil is changes. This phenomena of production of the EMF in the second coil, which is not in the contact with the first coil, this phenomena is called as the mutual induction. समजलं? समजलं? Self induction and mutual induction. Anybody has doubt? कोणाला नाही समजलं? सेल्फ इंडक्शन म्हणजे काय? पहिल्यांदा बघा, सेल्फ इंडक्शन परत एकदा मी सांगतो. Whenever current is flowing through the first coil, any coil, पहिल्यांदा सेल्फ इंडक्शन बघूया. Whenever the current is flowing through the any coil, it will produce the magnetic field around the coil. So whenever the current is flowing through the first coil, any coil, it produces the magnetic field around it, and it produces the magnetic field, and due to the creation of magnetic field, the magnetic flux in the coil changes, and so therefore, according to the Faraday's law, whenever there is a change in the magnetic flux, EMF is induced in the coil. So whenever the current is flowing in the coil, the EMF is induced in the coil. This phenomena of production of EMF in the coil, this is called as the self-induction. Okay. आता mutual induction म्हणजे काय? In case of the mutual induction, we require the two coils which are very close to each other. They are in not touch. They are in not contact like this. They are just close to each other. So whenever current is flowing through the first coil, it will produce the magnetic field around it, and the second coil, it is in the region of that magnetic field. So the EMF of the the flux of the second coil changes. As the flux of the second coil changes, its EMF changes. So that's why there is a production of EMF in the second coil. If we are given current to the first coil, आपण पहिल्या कॉइलला करंट दिलं तर सेकंड कॉइल मध्ये ईएमएफ तयार झालेला आहे. दिस फिनॉमिना इज कॉल्ड एज द म्युच्युअल इंडक्शन. ठीक आहे, समजलं सर्वांना? सो आता आपण काय काय शिकलो? पहिल्यांदा आपण शिकलो इलेक्ट्रोमॅग्नेटिक इंडक्शन. हा, आता आपण एक्झाम पॉइंट ऑफ व्ह्यू आपण विचार करू. तर याच्या ठिकाणी तुम्हाला ऑब्जेक्टिव्ह मध्ये काय काय विचारू शकतात बघा. Faraday discovered whenever the magnetic flux passing through the circuit is changes. आता याच्यावर विचारू शकता. चेंजेसच्या ऐवजी मग काही लिहू शकता. चेंजेसचे ऑप्शन देतील तुम्हाला. काही दिवशी चेंजेस, इट इज अप्लाइड, अशा प्रकारे. सो हे वाक्य लक्षात ठेवायचं. द प्रोडक्शन ऑफ करंट, द प्रोड्यूस्ड करंट इन केस ऑफ द इंड्यूस्ड ईएमएफ, इट इज कॉल्ड एज द इंड्यूस्ड करंट. इंड्यूस्ड करंटच्या ऐवजी इंड्यूस्ड करंट रिकामी जागा राहील. मग तुम्हाला ऑप्शन मध्ये येतील इंड्यूस्ड, वेक्टर करंट, पोटेन्शियल करंट, अशा प्रकारचे वेगवेगळ्या देऊ शकतात. तिसरा इलेक्ट्रोमॅग्नेटिक इंडक्शन इज द फिनॉमिना प्रोडक्शन ऑफ ईएमएफ. ईएमएफच्या ऐवजी व्होल्टेज, करंट, अशा प्रकारे देऊ शकतात. व्हेनेवर द मॅग्नेटिक फ्लक्स विथ द कॉइल इज चेंजेस. तर मॅग्नेटिकच्या फ्लक्सच्या ऐवजी ऑप्शन मध्ये देतात इलेक्ट्रिक फ्लक्स, मॅग्नेटिक फ्लक्स किंवा आणखी इलेक्ट्रोमॅग्नेटिक फ्लक्स, अशा प्रकारचे वेगवेगळे ऑप्शन देऊ शकतात. तर अशा प्रकारचे आपण ह्या गोष्टी आपण लक्षात ठेवलेला पाहिजे. ओके. आफ्टर दॅट आपण नंतर काय शिकलो? फॅराडेज लॉ. फॅराडेज लॉ मध्ये तुम्हाला हा जो पॉइंट आहे, द production of the magnitude of induced EMF at any instant is directly proportional to the rate of change of magnetic field. आता directly proportional चे ऑप्शन देऊ शकतात, डायरेक्टली प्रोपोर्शनल, इन्व्हर्सली प्रोपोर्शनल, आणखीन रिसिप्रोकल किंवा आणखी इक्वल टू किंवा नथिंग, याच्यापैकी एकही नाही, अशा प्रकारचे ऑब्जेक्ट येऊ शकतात. तर हे आपल्याला एक महत्त्वाचं लक्षात ठेवायचं आहे. द मॅग्निट्यूड ऑफ इंड्युस्ड ईएमएफ एट एनी इन्स्टंट इट इज डायरेक्टली प्रोपोर्शनल. ओके, सो अशा प्रकारचं हे येऊ शकतात. आणखी याच्यामध्ये हे एक येऊ शकतात, ई इज इक्वल टू, हा जो आहे ई इज इक्वल टू ई इज प्रपोर्शनल टू डी फाय बाय डी. सो ई प्रपोर्शनल, व्हॉट इज द करेक्ट, ई प्रपोर्शनल टू ds बाय dt काही लिहू शकतात अशा प्रकारे. ओके, अशा लेंजेसला म्हणजे मग येऊ शकते असं ई इज इक्वल टू मायनस डी फाय बाय dt प्लस डी फाय बाय dt किंवा डी फाय बाय dt स्क्वेअर किंवा डी टू फाय बाय dt स्क्वेअर अशा प्रकारे. तर यात लक्षात ठेवायचं ई इज इक्वल टू मायनस डी फाय. ठीक आहे, एनीबडी, कोणाला काही डाऊट आहे याच्याबद्दल? सेल्फ इंडक्टेशन बद्दल तुम्हाला सांगितलं जाईल. हा, कोणाला काही नाही समजलेलं आणखी? एनीबडी हॅज डाऊट? सर्वांना समजलेलं आहे? हॅलो, आवाज येतोय का माझा? हा, सर्वांना समजलं? एवढं समजलं ना? हा ठीक आहे. हा, उद्या आपण मग ट्रान्सफॉर्मरचं बेसिक बघूया. ते पण मी जे सांगितलेलं आहे त्यांना लक्षात ठेवायचं. ओके, आणि जेवढ्या मी आता हे पॉईंट्स दिलेले आहेत, हे अपोजिट, डी फाय बाय डी टी या प्रकारचे, हे तुम्ही वेळ भेटले तर आपण, मी जेव्हा असं शिकवत असताना आपण आपल्या नोट्स मध्ये लिहून ठेवून द्यायचे. इज इक्वल टू मायनस डी बाय डी टी. निगेटिव्ह साइन इंडिकेट्स दॅट इट इज ऑलवेज अपोजेस. अपोजेस त्याऐवजी मग वेगवेगळे शब्द देतात, अपोजिस, सपोर्ट, अशा प्रकारे. ओके, सो इट इज सफिशियंट फॉर टुडे. उद्या परत 10 वाजता आपण परत भेटूया and we will continue this. Okay,
okay sir,
bye.